Let's do this again. So I'm starting right here with this polynomial. So I have x squared minus 2x minus 25 divided by x minus 7. So if I use synthetic division, what am I dividing by? Dividing by the root, positive 7. So I put a 7 here, and I put it in a little box. And then what do I put here in this space? The coefficients, right? So what's the coefficient of x squared? 1. And then I have a negative 2 and a negative 25. So the first term we bring down, and we just multiply. 7 times 1 is, and we add these together. Negative 2 plus 7 is 5. And then we repeat that step. 7 times 5 is, and when we add these two, we get, and this is my remainder. So that means that if I evaluate this polynomial by letting x equal 7, I better get 10. Let's check it. 7 squared minus 2 times 7 minus 25. Let's see, that gives me 49 minus 14 minus 25, which is 49 minus 39, which equals 10. Again, these are the same. These are the same. So we also use the remainder theorem to determine if the polynomial that we're dividing by is a factor. We also use it to determine if it's a factor. So let's look at example C. I'm going to use synthetic division again instead of long division. So what am I going to divide by? I'm going to divide by negative 3. Good job, you guys. Dividing by negative 3. Let's see. My coefficients are 2, 11, and 11. I bring down my 2, and then I multiply. Negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 3 times 5 is negative 15. And 11 minus 15 is negative 4. So I better get like when I evaluate this polynomial, I better get negative 4 as my answer, or this whole idea that we have has failed. Here's a big mistake that I've seen some of you guys make. When you substitute in for a variable, you put it in a parenthesis. So what is the quantity of negative 4 when I square it? Is it it's negative 16, right? What's negative 4 squared? It's positive 16. We've been making boo-boos with that. Okay. Plus 11 times negative 4 plus 11. Let's see. So 2 times 16 is 32 minus 44 plus 11. Let's see. God bless you. 30. Yeah, I did something wrong. Oh, negative 3. Yeah. So sorry, you guys. So sorry. Yeah, this is supposed to be negative 3. My bad. Start that all over again. I'm dividing by the root. I apologize. So negative 3. Thank you for that. I would have just kept on going trying to figure out what I did wrong. So 2 times 9 is 18 minus 33 plus 11. So that's 18 minus 22, which is negative 4. And we are, in fact, the same. So let's do this one, long division. What am I dividing by? Chris, what am I putting in the box? A positive or a negative 4? Negative 4. What are my numbers, my coefficients that I'm putting across the top? Perfect. 3, 7, and negative 20. So bring down my 3. Negative 4 times 3 is negative 12. 7 plus a negative 12 is negative 5. What's negative 4 times negative 5? What happens here? No remainder. So what does that mean? Yeah, it means that when we evaluate it for negative 4, that this better equal 0. Let's see, 3 times negative 4 squared plus 7 times negative 4 minus 20. Negative 4 squared is 16 times 3 is 48. Minus 28 is positive 20. Minus 20 is 0. But really, it means that what? X plus 4 is a factor of the 3x squared plus 7x minus 20. And that negative 4 is the root. So we use the remainder theorem to just see if the number that we're dividing by is a factor. So that's really what we're going to use it for. We're not going to keep dividing to prove it. We're just going to evaluate it. So if you flip over on the next page, we're just going to start evaluating. We are just going to evaluate and see if it is divisible. So the first question says, if x squared minus 11x plus 22 all over x minus 9 is placed in this form, meaning it says, hey, I want you to divide it. Tell me what the quotient is and what the remainder is. This is the quotient. This is what you get when you divide it. We're trying to solve for the remainder. So we can use the remainder theorem that says use the root, which is what? What is the root of x minus 9? It's 9. Yeah. So use the root and plug it into this to see what your remainder is. So I'm going to evaluate the polynomial at 9. So I have x squared minus 11x plus 22. Well, x squared is 9 squared minus 11 times 9 plus 22. Well, that gives me 81 minus 99 plus 22. So what is that? Calculator bunny. Is it negative 4? It's positive 4. So my remainder is positive 4. So if you have a question that asks you, is this a factor or what is the remainder? You don't have to use long division. Just evaluate the polynomial at the root. That's like the whole idea, okay? So it says, by definition, the binomial that we're dividing by is a factor of the polynomial if, when we evaluate the polynomial or when we divide the polynomial and we get our quotient, our remainder is what? What happens to our remainder? We know this is a factor if the remainder is, okay, so go back here. We know that the binomial is a factor of the polynomial when the remainder is 0. We know that the binomial is a factor of the polynomial when the remainder is 0. That's what we know. So that's all we're going to do. We're just going to keep evaluating these by the root and see if the binomial is a factor. So question A says, is x minus 3 a factor of the polynomial x squared minus 11x plus 24? So we're going to evaluate it at p of what? 3. So that equals 3 squared minus 11 times 3 plus 24. So let's see, we get 9 minus 33 plus 24, which equals what? Someone calculate it. What is 9 minus 33 plus 24? Brain power. Go, go, go. 0. It's 0. So what does that mean? Is x minus 3 a factor? Yes. Yes, because r equals 0. You have a remainder of 0. Okay. Does that make sense? Okay. Let's evaluate it again. So we're going to do a new polynomial and a new binomial. So we're going to use x plus 5. So what am I really evaluating this polynomial at? Negative 5. So I have 2 times negative 5, the quantity squared, plus 9 times negative 5 minus 2. So that gives me 50 minus 45 minus 2. Well, 50 minus 45 is 5. Minus 2 is 3. So is x plus 5 a factor of 2x squared plus 9x minus 2? No, because r does not equal 0. Or better put, I guess, to say that p of negative 5 does not equal 0. Okay? Are you understanding this? Okay. Jack, C, what am I evaluating that polynomial with? What is x going to be? Like I'm replacing the x with a what? What? My root. If x plus 1 is the expression, remember that this equals 0. So my root is what? Negative 1, right? Okay. So we're going to let negative 1 be what we substitute in. So p of negative 1 equals negative 1 cubed minus 7 times negative 1 squared minus 11 times negative 1 minus 3. So let's see. P of negative 1. Negative 1 cubed is still negative 1. Negative 1 squared is a positive 1 times a negative 7 is a negative 7. Negative 11 times a positive, sorry, times a negative 1 is a positive 11 minus 3. So negative 8, yeah, it equals 0. So yes, x plus 1 is a factor because p of negative 1 equals 0. No remainder. Do we need to do D? Okay, I'm going to just do it really fast. So P of 5, I get 125. I'm doing it in my brain. Is that okay? Minus 25, minus 195, minus 10. So that's 100 minus 195, which gives me a negative 125 minus 25. Minus 19 times 5 is 195. So 100 minus 95 is negative 95, right? Minus 10. Is someone doing that for me? I think I get negative 105. Yeah. So is this a factor? No. Do we end up that P of 5 equals 0? No. So question 5 is really interesting because it asks you, so what does K have to be? What does the value of K need to be in order for x minus 4 to be a factor? So what would we be evaluating this at? We would be evaluating it at a positive 4, right? And if it's a factor, what do we know? It has to equal 0. Yeah, so let's just plug that 4 in there. So I have 4 squared plus k times 4 minus 52. And I know that if it's a factor, it has to equal 0. When I evaluate it, it's going to have to equal 0. So let's see. That's going to give me a positive 16 plus 4k minus 52 equals 0. And I'm going to combine these two terms. And that gives me a negative 36 plus 4k equals 0. And I'm going to subtract or add 36 to both sides. So that gives me 4k equals 36, which means that k equals 9. What do you think? No? Yes? Yeah, I think this one's cool because you don't have to use long division all the time to determine if something's a factor. Just plug it into your calculator. And if you get a remainder of 0, you know it's a factor. If you don't get a remainder of 0, you know that you're going to have to figure out what the quotient part is, right? So you're still going to have to use the division, long division, but you know what the remainder should be. So you know if you're doing it right or wrong. So that's how this works, okay? Questions on the remainder theorem? You look fabulous in your glasses. You don't wear them all the time. I love them. Okay, you're welcome. All right, I'm going to stop this video.